This is Anna Timpencil with Developer. I'm a certified cryptocurrency auditor and a certified blockchain developer, and I'm here to teach you all today about C++. And I really wanted to kind of dive into a bit of the history because I think it's really important to know and like when to choose it. And in my last video of C, you'll probably see why a lot of people choose C++ over C. So just kind of a brief history of C++. When Ken Thomas and I think his name is D. Ritchie rewrote the Unix OS in C, a guy named Bjane Straub began developing C with classes, like in quotes, like that it was literally called C with classes, just like that. And C with classes was renamed in 1983 to C++. And then from there, we have in 1985 the first commercial C++ compiler, which was called Seafront, which was released by AT&T. That's right, that was the phone. It still is the phone company. And in 1989, C++ 2.0 standard was released. And then 2011, we had a major update with C++ 11 standard released. The most recent that I remember, like in terms of, there's more of a minor update, not as major as the 2011, but it would be C++ 14. So that's just a little bit of the history. But C++ is what we call object-oriented programming. So programming has many like paradigms or styles that they use to write the program. So like there'll be like procedural, which would be like C, Fortran, MATLAB. There's data flow, which would be like Simulink, VHDL, LabVIEW. Functional, which is like Excel, Lisp, F#. And object-oriented programming, or OOP, basically seeks to define a program in terms of things in a problem. So like files, buildings, cars, modules, and what they need and can do. So if that makes sense, object-oriented programming basically just defines a class and represents these things. So like, let's say you have a car. You can hear my cat running around. The class would be the car. Like the steering wheel would be the public interface, and like the powertrain and the motor and the batteries or whatever would be like the private data and the methods. So OOP defines classes to represent these things. The classes contain the data and the methods, i.e. the internal function, and classes also control access to the internal data and methods. So a public interface is used by an external code when using the class, and it's a really highly effective way of modeling like real world problems inside of a computer program. And kind of compared to some other languages like, C++ compared to Python, C++ is compiled, whereas Python's interpreted. Both are pretty strong. Variable safety for C++ though is kind of unsafe compared to Python. C compatibility is nearly 100%, whereas Python is like not directly compatible. And then relative speed is pretty fast compared to Python. So just kind of like a little comparison, because we've talked about these things before. So you're probably wondering, when do you choose it? Despite the competitors, C++ has remained popular for like the greater part of 30 years and will probably be popular within the foreseeable future. And you're probably wondering why. So complex programs and problems can really be effectively implemented, and OOP works all over real world, virtual world. And there's not really a lot of other languages like C++, because it really like brings together like performance, expansiveness, and the ability to handle like complex programs. So when you choose it, when you choose C++, you would choose it when program performance matters, when programmer productivity is less important. It's faster to produce code, working code in Python or R or MATLAB or like other scripting languages, but this is a great tool to have. You would also use it when the program language itself can help organize your code. Like, not everything is I'm not sure if you hear this cat meowing. She's on one right now. So not everything is like a vector or matrix like MATLAB. and then access to libraries that will help with your problem. Basically, a pro is that it has so many available libraries, but another con with that, like the kind of a double-edged sword, is that it's a very large language, and I honestly won't be able to cover nearly all of it ever. It's pretty flexible for programmers, so you can like have high and low levels supported, so like objects and like fiddling with memory isn't going to be an issue. There's no automatic memory management, so you're in control of memory usage, which is like chef's kiss. It's compiled, it's strong type system, it's high performance. The con is that there's obviously no automatic memory management, so you are in control of the memory usage, which a lot of people are like figuring out how to delegate memory is like one beast in and of itself. But if you're someone who needs to have control of that, this is your friend. This is great. It also includes all the sublets of C and adds its own, and then generally requires careful attention to detail. So, and there's a quote by Steve Taylor. It's C++ is an octopus made by nailing extra legs to a dog. And I digress. So let's go ahead and get to the basics of syntax and functions of the C++ programming language. So I will start here with count. It basically just prints output onto the screen. So it would be like written like this. Count would be written. This is C++. Quote and end. Syn, it takes input from the user. So if I wanted to get someone's name, I would write syn variable underscore name, and that's how I would get the name from the user. So that would be like the very basic of the start of that. And then we can talk about character types. So typically a single or like 1 byte would be an integer type. So that would be let's say variable name. An integer type, which is the most natural size of an integer for the machine, we would write that as in variable name. A float type, which is just a single precision floating point value, is written like float variable name. And then there's also a double precision floating point value, and that's just written as double. And then variable name. The variable name is just so you can see something. You don't actually have to write variable name. That's just, a placeholder for this. And then we can do void, which basically just represents the absence of the type, and that's just written as void. And then Boolean, we just write that as bool. That's a Boolean type. And then we can get into escape sequences, which is basically a sequence of characters starting with a backslash, and it doesn't represent itself when it's used inside a string literal. So something like a \a would produce like a beep sound. Backspace would be \b. Form feed would be \f. A new \f, that's form feed. \n would be for a new line character. Carriage return, I think it would be \r. I'm thinking I got that right. Oops. And then if you want to give a tab space, like if you were to use the tab key, you would just do a \t. For a backslash itself, you would just do 2 backslashes. for a single quote, you would just do / single quote. For a question mark, you might be seeing the trends here. Just a / and question mark. For an octal number, which represents the value of an octal number, you do a / n. So 3 n's. And then you would do for hexadecimal number, x, h. So we have 3 n's and xhh. And if you want a null character, which is usually used to terminate a string, \0. So let's jump also now into comments. A comment is a code that's it's not executed by the compiler, and the programmer uses to keep track of it in the code. You guys have seen this. I do this a lot when I want to write something. This is a single line comment. Nothing is read here. And then we've also done multi-line comments before, but let's just go over it again. You would do /*, and then you would write, hi, I'm, a multi-line comment. We can close it up. Just like that. Close up the same way we started, with a star and a /. So that would be the single line and then the multi-line. So let's jump into some strings. Y'all probably remember, or if you don't, that's fine. Strings are a declaration of characters surrounded kind of by double quotes. So like a declaring string would be like written. Sorry, I have still recovering. Include. And we write string. That would be to include the string library. And then we would say string variable 1 equals hello world. There you go. And then the append function, it's used to bring two strings together. So that would be, let's say if it's going to be my name. So we're going to have string first name equals Anna. String last name equals 10 pencil. String full name, first name, append, last name. And then you would use count with the arrows and say full name. There. That would be use of an append function to make my first name and my last name into the full name. And then a length function. Basically, it just returns the length of the string. So that would be written like string variable 1 equals developer count the length of the string is, and then like that. So then accessing and changing string characters, we would have this as string variable 1 equals hello world. Then we would say variable, if I could spell it correctly, use the array 1 equals I, and then write count variable 1. I always forget to end them in semicolons. So then let's go into math. So C++ provides some built-in math functions that can help like any programmer to perform mathematical operations efficiently. So a max function will return the large the larger value among the two. So you would write something for a max function like count max, let's say 10 and 150. That's how you would write that. And then same for the min function. The min function returns the smaller value among the two, so you would write that as count min, say 150 and 50. Then we have the square root function, which returns the square foot of supplied number. So we would do hashtag include, and I would say cmath, and we would write that as count. SQRT, which is square root of 144. That's what I'm using as my variable. A ceil function, which is CEIL, it basically returns a value of x rounded up to its nearest integer. So you would write that like this. And then same with the floor function, it returns a value of x rounded down to its nearest integer. So that would be written like that. So you have ceil and floor, like ceiling and floor. Then the pow function basically just returns the value of x to the power of y. So that would be pow, like power, x, comma, y. There you go. So if y'all remember in the other video, we talked about if else, do while loops. You can still make those conditional statements here. Conditional statements are just used to perform operations based on some condition. So obviously the if statement, you'd write that here. You would say if, and then you write the condition, and then you would do your little curly brackets, and then you would write the condition, or write the code rather. And we're going to say the same for if. You'd say if condition, constant, oh gosh, condition, I can't spell today. And then you would say code, and down here you would say else. So if the code is not met, if it's met, otherwise, if it's not met, do this thing instead. So that would be the if, and then the if else. And then there's also if else if statements, which I do think is kind of important to know. So if you have if condition, then you have the statement, then you have here, if condition, else. You can do else if condition. And you go down here and you can just say essentially else, and you can go ahead and write in something in there for that. A ternary operator is basically shorthand for an if-else statement. So if you don't want to write all this out, you just write, variable equals condition. Let's do that. And I would say like expression true, expression false. Yeah. For a switch case statement, a switch case would allow a variable be tested for equality against a list of values, i.e. like a full case. So I would write that as like switch expression case constant expression, and then I would have statement 1, statement 2, and then I would have the break, And then I would say something like case constant expression, probably statement, break, and then, you know, blah, 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 default statement, and I would just end it there, most likely. So that would be like a switch case statement. And I'll just show you a quick while loop, because a while loop, well, it's an iterative statement, so it facilitates programmers to execute like any block of code repeatedly and can be controlled per the conditions. So the while loop iterates the block of code as long as the specified condition is true. So for this, a while would be condition, and then we would say code to be executed. A do while loop is an exit controlled loop, which is similar to the while loop, but with one main difference, i.e. the body of a do while loop is executed at least once, even if the condition is false. So we have a do, and then the code, and while condition. So do something while this condition is happening. So for loop is used to iterate the statements or a part of a program several times, which is the frequency used to traverse data structures like an array in a linked list. So I would write that for this as for init I equals 0. And then I would say I is greater than the count. And then say I plus plus. And would write in then the code I wanted to use. And within the curly brackets. And we saw up here that I used a break statement. The break statement keyword inside a loop is used to terminate the loop. So that's just written like this. And then a continue statement is a continue keyword that skips the rest of the current iteration of the loop and returns to the starting point of the loop. And that's literally just written as continue for this case. And then references. So a reference is an alias for an already existing variable. So once it's initialized into a variable, it cannot be changed to refer to another variable. So it's a const pointer. So creating a reference, you would say something like string var1 equals value 1, which basically means the var1 variable. And then if I wanted to say string and var2 equals var1, that just references variable 1 or value 1 as we have it written. So a declaration pointer is a variable that holds memory addresses of another variable. So we can say, write it like data type var name, and then write var name equals and variable 2. There you go. That would be declaration. So functions and recursion. Functions are used to divide an extensive program into smaller pieces, and it can be called multiple times to provide reusability and modularity to the program itself. And we've used functions before. We've also used variables before, but let's go ahead and see how we would do that in C++. So let's say we have a function definition. We would say return type, return type, and write it as function underscore name. And then let's say data type parameter dot dot dot, and then we write inside of this the code to read. And it's that simple. And then we could also do a function call, which is just a function name, and then we could write something like arguments. A recursion is when a function calls a copy of itself to work in a minor problem, and the function that calls itself is known as a recursion function. So I would write something like that as a void recurse. Throw some brackets in there, curly, and I would say, and then recurse, and then, you know, write whatever I needed. Just like that. So I briefly talked about in the beginning object-oriented programming, and I just want to say that it just really is programming approach that primarily focuses on objects and classes, and the objects can be really truly any real world entity. So I would write that here as class, and then say class underscore name, and I would write public, which is the access specifier, which means the public can see this. I can also do private, I can do other things, and then within that I could say, you know, any functions, any blocks, any fields, etc. And then I would just close that up. And then the object version of writing this would be class underscore name, and then say object name. And then constructors are a method that's called automatically as soon as the object is created. So let's say we're going back up here again. I could go after public, I could say class name, and I could write count develop her, and I could then write int main, do some curly brackets, say class name obj name, and then just say return 0. Just like that. And if I wanted to go a little bit more, I could do like a data encapsulation, which data encapsulation is a mechanism of bundling the data and the functions that are used in them, and data abstraction, which is a mechanism of exposing only the interfaces and hiding the implementation details from the user. And that's a little bit longer, so bear with me. We're going to include, do hashtag include, this is how I would write it out. IOStream, use namespace std, doesn't mean what you think it means, standard. I would say class example encap, and let's curly bracket this and say private. Since we've only marked these data members as private, any entity outside of this class will not be able to see it directly, and they'll have to use like a getter and setter function. So we'll say private, and we'll say init num, let's say char, and then we could say public, which is a getter function to get the value of data members. And since these functions are public, these ones could be accessed outside of the class. Obviously, this provides then access to data members through them. So we could say, if this is the information we wanted to have public, we would say, oops, int get num, and then we'd say const, and within that return num. We could say char get ch and write const return ch. And this is the setter functions that are basically called to us for assigning the values to the private data numbers or data members, sorry, not numbers. And then I could say I want a void set num, where I could write this arrow number equals num, and then I could say void set ch, which I would write as this, and there's some curly brackets in there, and do the same thing with the arrows, just like that. And then we could set a into main example encap object set num as 100. Let's set it as 100, and then we set the character as a single quotes, and then we count object get num and 1, and then we could say that again, count get ch, and it's not 1, it's an L. I'm silly. And we would finish it up by saying return 0. So that would be data encapsulation. So let's talk a little bit about file handling. File handling just refers to reading and writing data from files. So C provides some functions that allow us to manipulate files. So let's talk about reading a file, which allows us to read a file line by line, and it's pretty straightforward. It's just get line. Opening a file would be, this would open it in C++, like in the program. It would be void open const character star, and then you would write like file name, comma, iOS, open mode. Write something like that. Open, so like an in would open a file to read. So that would be like fs open, and you would write, I don't know, your document name. So I'm going to say big cat, in quotes, big cat text. And we could have it of stream, so we could say std f stream out, but you want to use the right. There we go. And we also want to make sure we close these because sometimes I forget one. You can also use a trunk. That's spelled like chunk. And that just removes the data from an existing file. And that's like fs open. Let's say we're going to do big cat text. And we would say std fstream trunk. You could also do like a no create, which is a file that already exists. You can do an 8, which opens the file, and all you would do is you change this out. So you would do, instead of trunk, you would do no create, or you would do 8 for opens a file and moves the control to the end of the file. You could also do opens a file and appends all of the outputs at the end, and that would be just this with app. And you can also open a file in binary mode, which you could just write binary, and also with no replace. And then if you want to close a file, we would say, I'll just say my file, close, and then throw some parentheses in there. So that is basically it for the start of C++. This will give you probably the most robust jumping off point for one of our next projects. And I hope you all enjoyed this video. Thank you so much for watching. I appreciate y'all putting up with me, especially when I'm sick. And I will see you guys in the next video. Goodbye.